So today's demo is going to be all about snapping animations from IK to FK or vice versa throughout an entire shot, specifically on a rig that does not have an FK IK snap tool. So for anyone who has used that, you know just how nice an FK IK snap tool is. For those of you who don't know what that is, essentially when you're animating, you have two modes in your arms. You have FK, forward kinematics, which is essentially you rotate from the base of your rig across, so you'd move your shoulder, then the elbow, then the wrist, and you manage through there. Then you have IK, inverse kinematics, where you move the wrist and everything up the chain, inverse, moves for you. This is great for placing your hand on something and then leaving it there, whereas FK moves more naturally and gets you beautiful arcs. And on certain rigs, you will have a tool that allows you to snap from one to the other. So let's say I put my IK pose here. I go, no, wait, I want my FK pose to be there. FK is still in the T pose. I just hit a tool, book, it snaps it in place, all good. That is super helpful. But some rigs don't have that. Some rigs, they're just not built in. So we have to do that manually. And oftentimes you can just repose it yourself. It doesn't honestly take too long to get a close approximation. But if you have to do it across an entire shot, it can be a pain. So I've got two shots here. These are shots that we animated on stream. So I figured, hey, I'll just use them again for the demo. So here we have a dance shot where I animated the arms entirely in FK. Now I'm just going to snap one arm for the sake of time. But we can see here, we've got all of this animation. The arms are moving in FK. Let's say I want this to be an IK. We're going to do that. Now I've got another shot here, another shot that we animated on stream. And this time I animated this hand all in IK. Once again, let's say I need this whole shot to be an FK. I can't have it in IK for whatever reason. Sake of argument. There. How do we do this? Well, first of all, I want to put a big disclaimer here. I should have put a big disclaimer on screen, big red warning. No method is going to work for every rig. Every rig is built differently. Every rig is going to have its own little quirks and details. The method that I've created here, I've tested on quite a few different rigs, and most of them have worked like spotlessly. It just works. There are rigs where like the elbow didn't snap correctly, it wasn't quite right, or there was a slight shift in the arm, it wasn't 100% perfect. Every rig is different and it really just depends. So do not take this as, well, it's the one way and it's always going to work. The big reason being FK and IK snapping is insanely complex to do it correctly. So to do it correctly involves a lot of mathematics and really trying to understand how things are going to switch between each other. Now, if anyone's curious, we can go a little bit into what is required to do a true FK IK snap and to do it properly. Honestly, it's a lot of trigonometry, a lot of math, complex math, a lot of trying to figure out perpendicular lines between three different points, and like it's a lot of graph math. So if ever you've done like the graphing in 3D space in mathematics classes, it's that on a moving object. The method that I'm going to be using is approximating a lot of those things. So it's never going to be 100% accurate, but it's going to be pretty darn close, if not like 99.9% close for most situations, again, for most rigs. So we're going to be using some of the Maya tools, and we're going to be using hierarchies in Maya to help us create all of this. Now, I'm going to be doing the demo here. Later on, I'm going to write up an actual document that I'll be sending out on the Pratt Bros Discord and on the AM Discord of the steps actually written out so you can follow it along. Right now I've just got like a super horrible short version notes that is illegible to anyone other than me because I'm just using shorthand for everything. But I'm going to write that in a nice clean way so everyone can follow along. Now, let's go over, let's go from IK to FK first. Typically, that is much easier to do. So here we have or I should say not from IK to FK, we want our IK to match our FK. So our FK arm is animated and we want the IK to match this. Now, why is this easier? Well, here's our rig. Let's actually just hide all of the controls except for the arm here. And the reason that IK is easier is because we're really only dealing with translations and a few simple rotations. And Blaze, thank you so much for the sub. Oh, thank you so much. 17 months. Jeez, thank you. Let's see. How can you write math looking nice with arcs? I like that. So let's see. Can my grease pencil work out here or is it going to crash? So with FK, you're dealing with a lot of rotations. You've got the rotations of the shoulder. You've got the rotation of the elbow. You've got the rotation of the wrist. And Miguel, thank you so much for the sub as well. Start the train. So we're going to deal with a lot of rotations. Not only that, but the elbow is often locked in rotation. So for example, on this rig, you only have the rotate Y axis. So that is natural. That is what most rigs will have because that's the way our elbow works. The elbow is a hinge joint. So you have 3 sets of rotations down here, 1 rotation down here, 3 rotations down here. That's a lot of different things. With IK, you just have your IK control. So you would have your IK control right here. That is just using translation right there. Where is it positioned? Pretty simple. And then you have the elbow, which is just a PV, pole vector, which just points to where it needs to go. So as long as you have the position of where the wrist is here and the position of the elbow here, you can pretty much get a good snap. The only thing that you are missing is the orientation of the hand. Which way is the hand rotated? We need those 3 pieces of information in order to properly snap from FK into IK. That's fairly simple. And with locators, we can easily mark all of those out. So let's do that right here. So the first thing we need to do is actually find the positions of the elbow and the wrist. Now, the way I'm going to do this is I'm going to make 2 quick locator hierarchies. So I'm going to open up my outliner here so everyone can see, and let's get rid of all of these just to simplify things. Okay, cool. So with that simplified out, I'm going to just start creating the very simple hierarchy. So I'm going to go to create locator. I'm going to create 1 locator right here, and we're going to be naming things here. You definitely want to name your stuff. Otherwise, things are going to get messy. So this is going to be our wrist locator. Okay, so we've got our wrist locator right here. This is going to be the thing that marks the wrist. Now, technically, I could put this right here, just constrain it to the wrist, and that's going to get most of what I need in place. Pretty good. The problem with that, just doing a straight constraint to that, is while it might give me the position very nicely, when I then try to snap the IK wrist to that locator in order to match it, and Miko, thank you so much for the sub as well. So when I snap it, it's going to be locked in place, and I'm not going to be able to make any small adjustments if the snap wasn't quite perfect. So a common issue you're going to have is, let's say I constrain the locator to the wrist there, and that finds all of my positions. Great. Now I snap the IK to that. For some reason, depending on the rig, the IK wrist might be this way instead of this way. So the whole animation, the character is doing this now instead of having the hand this way. It's just bent. So we don't want to do a straight constraint because we lose the ability to readjust that and fix the shot in 2 seconds. So we've created our wrist locator. Now I'm going to create a quick hierarchy. So I'm just going to group this twice. Group, group. The way I did that is just hit Control G. You can also do that by going to Edit, Group right here. Now, do you need 2 groups? No, you could get away with 1. I like having 2 just in case. It just gives me that extra little stability. So let's name these. The first group here is going to be our wrist. And my keyboard is way off to the side here, so it's not the optimal position. So it's our wrist rotation. I'm just going to write ROT here. Rotation offset. And then I usually add GRP at the end, just so I know that it's a group. So it's our wrist rotation offset. This is the thing that's going to be used in case we need to readjust that hand, just in case. And then we have our wrist constraint group. Okay, so this is the group that we're going to use to actually match the hand to the wrist. That way it follows along and we get everything that we need. So we have this very simple hierarchy, a locator within 2 groups right here. Okay, now before I do anything else, let's just kind of move this to the side here. I'm just going to duplicate this whole hierarchy. And now I've got another one, and I'm going to use this for the elbow. So I'm just going to rename this elbow. And we're just going to rename that throughout the whole thing. There we go. So once again, we've got an elbow locator. This is going to track where the PV should be. We've got a elbow rotation offset. This is going to allow us to rotate to make sure that the PV is in the correct spot and not like 90 degrees off or something like that. And then we have the constraint, which is actually going to be the thing that follows along so we can track the motion. Okay. So far, kind of complex, but not too bad. Now, what we want to do is just constrain the top level groups, the constraint groups, to the controls we want. So with the wrist constraint, we are going to constrain that to the FK wrist. That's going to track the wrist as well as give us all the directions we need, all the rotations. So I'll select the wrist first, then the group right here. So not the locator, but the group right there. Constrain parent, and I'm going to make sure maintain offset is turned off right here. This way it snaps it into position. And sleep deprived, thank you so much for the gifts. Jeez, thank you so much. That's super generous of you. And Edward, hello. And did I see Noelia in here? Noelia, hello. I thought I saw Noelia. Maybe not. I saw it in the corner of my eye. So let's see. We're gonna have this awesome song for a while. I love it. Okay, so I've constrained the group to the hand, and now it's snapped to it. And as you can see, the locator is now in place right here, and it's tracking along. Now, again, why do we have these rotations? Well, if for some reason, let's say, sake of argument, this locator was ever so slightly twisted like this. If for some reason it's not tracking quite right, I can use the rotation offset to realign that with the hand, and then I'm going to be all good with the tracking information. So that's why we have that other offset there. In this case, it's pretty much perfect. So there we go. So we've got this done. Okay, that's tracking the wrist. Now we need to track the elbow. I love this song. So to track the elbow, we have a few different things we can track. Typically, you should be able to track the lower arm FK control, because that's going to track from the elbow pivot right here, right at the elbow. You can see there's my pivot point right there. So if I take my second elbow constraint group here and constrain it to the arm, so lower arm first, then the group, constrain parent, you'll see that allows us to snap it right there. Perfect. Now, this is tracking the elbow, which is great. As we can see, it's moving along with the elbow, all fine. But when we are going into IK, we do not want to track the elbow position. We want to know where the elbow PV is going to go. Now, the pole vector, this is where if you're trying to do it mathematically, it becomes very tricky, because the proper way to track the pole vector is to figure out the point here, where the wrist is, where the shoulder is, and then where the elbow is. You have to figure out the math for this triangle, find the intersecting point here at a perpendicular angle, and then draw a distance out over here. That's going to find you where the PV should go. That's a lot of math. And that triangle changes the whole way all the time as you're moving. So, no, not for me. I don't want to do that. So what we're going to do is we're going to use this little hierarchy that we've done to get pretty much close to where we want to go. The PV, there's a lot of wiggle room. As long as I get it pretty close to where it should be, I'm going to be good. So the way I'm going to do this is the locator here, you'll notice that it's not constrained. The thing that's constrained is this top level group. That means that I can just take this locator and I'm going to just translate it out in Z right here. And I'm just going to bring it out, maybe like -60. Let's just keep it nice and simple. -60 right there. So this is now that pivot point, that pole vector locator. And you can see that now it's staying out away from the arm. Perfect. Now the problem here is that this is not going to track correctly. It's to the front. We want that to be perpendicular to that kind of invisible triangle here. This is where I can take this rotation offset, and I'm just going to take this and whoop, rotate it like so. There we go. Done. Now it's pointing behind that arm pretty much the whole way. Now, depending on the rig, that's all you need to do. You just kind of move it in there and you're good. Depending on the rig, sometimes that's not going to work. As you move that arm and as it straightens and bends, you're not going to get a consistent point that's away from the elbow. It's going to be like rotating out and around. So if that you do run into that issue where you're trying to keep it between those 2 points and it's just fighting you all the time, what you can do is add a second group. And jeez, thank you so much for the subs. Is that Poor Peasants? Thank you so much. Oh, I really appreciate that. I'm not sure. It's just showing me the Japanese here. And I can read a little Japanese, but not enough. Or is it Japanese? Maybe not. Maybe it's Chinese. Thank you so much. I really appreciate that. Okay, chicken mushroom stew. There you go. Okay, you changed your name. Welcome. I like the new name. Thank you so much. I really appreciate that. So, more dancing. I love it. So the problem here is that we need to essentially create a little bit of a calculation between the elbow and the shoulder. As this changes, this angle here changes, we need that pole vector to be able to track between that. That's going to be complex. That's really hard. How do we do all of this stuff? Actually, it's much easier than you'd think. All you need to do is add a second constraint. So I've constrained it to the elbow here. As I move the elbow, you'll notice that that adjusts here. And you can actually see the offset that I was talking about here. As I straighten that, see how that locator is now offset? It's not out here. So what I need to do is have it calculate between these two objects. So I'm going to take the upper arm now, take the locator, constrain that as well. And this time I'm going to make sure, and actually not the locator, sorry. Upper arm to the elbow constraint group here. And I'm going to just add that. And now, as I adjust this, let's get this back into position using our rotate offset. So right around here. And actually, I just want to make sure. See how the pivot point moved there? My settings weren't set correctly. So again, upper arm, constrain group, constrain parent. We want to keep that at the elbow, so you want to make sure maintain offset is turned on here. Now, as we rotate, we should get this, and see how it stays in line? Imagine that triangle right there. So I'll just draw it out so we don't have to imagine. You draw a triangle here, here, perpendicular line. It's pretty darn close now. So it's finding the difference between those two for us. Haha! We've gotten that pretty darn close. At this point, I can just use the elbow offset right here to get exactly where I need to be. Typically like a 45-degree angle should get you pretty much mathematically accurate there. And now, as our arm moves, and I just realized I tweaked my animation here. Yeah, bring that back. Hopefully that's going to be far enough. Okay, yeah, that should be pretty good. Now, that PV is going to be right in the correct spot the whole way through. So, we've got our 2 points right there. We've got our wrist tracker, we've got our PV tracker. There we go. At this point, all I need to do is snap the IK controls to these 2 points. There is going to be an issue here, which is they are tracking the FK controls. Depending on your rig, if you switch to IK, it might switch their positions. Let's see what happens here. So I'm actually going to delete the animation on the FK IK switch here. Okay, cool. It stayed in place. See how these stayed right there where I needed them to be? Those are tracking the FK positions. If for some reason when you switch to IK, it's readjusting your FK positions here, those locators move, what you would want to do is bake out the animation on your top level groups here. That way it keeps that exact position, and then we can constrain and fix the repositioning. In this case, I don't have to worry about that. So at this point, we've got our animation, and you'll see that the IK arm is sticking in place, and it just creates this funny little odd motion there. Little fingers pointing at the end there. Just blink. But you'll notice that the locators are moving correctly through the scene. They're tracking everything. Okay. So at this point, all I need to do is take my IK controls and constrain them to my locators. So I'm just going to, for the sake of making sure nothing breaks, delete any animation that's on the PV control and the wrist control right there. If you do have animation, it's not a bad thing. In this case, it's not going to be doing anything anyway. So let's start with the wrist here. I'm going to select my locator first, then the IK control, and I'm going to go to constrain, and I'm going to parent it. And this time I want to turn off maintain offset, so it snaps in place. And overall, I think that's the correct position. So if I switch between FK and IK, haha, you can see that hand is exactly right. If for some reason the hand is in position and then you switch back and forth and it's like rotating oddly, this is where you would then use that wrist rotation offset to realign that wrist back to where it should be. Now, from there, I'll do the same thing with the PV control. Now the PV control is a little different. You'll notice that the pull vector, it only has translates. So I can't really do a parent constraint because a parent constraint does translates and rotates. I could by going through the options, but that's more pain than it's worth. So instead, I'm going to select the locator, then the PV, go to constrain, and I'm going to do a point constraint. A point constraint only constrains translations. So with here, make sure maintain offset is turned off, and there we go. Now the arm follows along and looks like I've got one key here that's a little out of place. What's going on here? So here, you always want to double check. See that how the elbow kind of snaps in right here? If I'm reading this correctly, what's happening is that my group here, one of the constraints, yeah, see that how it's, because I've got that double constraint, it's fighting me on that one frame right there. This is the joy of elbow PVs, is you often have to fight to get the right positioning. So let's actually just turn off that one constraint. That's the one I did to the shoulder. And I'm just going to double check the positioning. Turn that on and off, go through, on and off. And you see, it actually doesn't make that much of a difference in this case, in this animation. So in this case, I could just turn that off and it's not going to make much of a difference. If I did find that, you know what, I need to keep it on for the rest of it, but this one frame is just killing me. Everything else is working, but this frame isn't. What I can do is just key this. So it's going to be on here, and I'm going to turn it off here. There we go. And now that elbow PV is perfect right through there. So always double check before you go in and start baking anything. So now the IK is following exactly where the FK is. At this point, all I need to do is transfer from constrained data into keyframe data. Right now, you'll see that the hand, the IK hand, is moving because of constraints right here. There's no keys in this. That's fine, but if I want to animate this and adjust the animation myself, this is going to be a pain. So I'm just going to take my IK hand right here, and I can also take the IK PV. I'm going to go to Edit, Keys, Bake Simulation. Now here, you've got a lot of different options. For me on this animation, I'm just going to set this to key every frame for this whole shot. So from 1 to 66 here. And the reason I'm doing it every single frame is just because at this point, because the shot is all polished, you can really start getting some weirdness if you're using the smart bake where Maya will decide where to put keys. I want this to be exactly the same as what I had before. So I'm just going to key it, have it so it samples by 1. It's going to put a key every single frame. So let's just bake that, goes through. And now you'll see there's no more constraints and the hand goes through. Now I can just delete these two groups, boop, boop, right there. And the hand is all in IK, matching exactly what I had before. So a lot of different steps here. We had to create the locators, group them together, constrain them to the elbow and wrist, move that PV or that locator out so it tracks where the PV is going to be, and then constrain the IK controls to that. Honestly, it doesn't take that long. Once you're kind of used to the steps, it'll take 2-3 minutes to get it all done. And now I've got the entire shot in IK compared to trying to manually pose that out, which that could be a pain and you're never going to get quite right. And I can always test this just by going back and forth. You can see FK, IK, exactly the same. FK, IK, exactly the same. So now our arm is in IK, all good. So that's the first way, snapping IK to FK, to match the FK, I should say. And that is the simple method because it's easier to track that information than it is to go the other way. Now, before we go the other way, let me catch up with the chat. And if anyone has questions on this, definitely let me know. Let's see, quick question. My shot, my character is crossing her arms and I want her hand to be locked on the bicep. I tried to use IK hands, but every time I move the spine, the hands stay in place. How can I lock the arms in place? Yeah, that makes a lot of sense. So it really depends on what you want. A lot of times if you have your characters crossing their arms and you want to stay along like this, what you can do is take your IK control and switch the space attribute. The space attribute, it's not always called space. Let's see what's it called on this rig here. It's follow in this case. The follow, the space attribute, it determines what the IK control will follow. So right now it's set to root, which means that if I move the root control, this big control here, the IK hand will follow that, but it won't follow anything else like this. However, if I take my IK control, I can switch this to follow different parts of the body. So for example, if I want the hand to follow the chest, I put my hand here, I could set this to chest. And now as I move the rest of the body, you'll see it's still an IK, but it's following along with the rest of the body. If I move the head, it's not following that. But if I switch the space to follow the head, now, as I move this, the hand follows the head. So, what you can do here is just find the space attribute that's going to give you the closest to what you need and have that follow along. Now, that might get you what you need. If it doesn't, what you would then need to do is constrain to the actual arm. So you want, let's say I have the arm here, cross the hands, and regardless of what the hands are doing, I want this to follow along. That's a really complex constraint setup, mostly because they're kind of crossing each other, and you can have constraints fighting itself. So typically when you're going to do that, you'll want to have one hand constrained to the other, and the other is leading all of the motion. So you're animating that one arm doing everything, and the other arm is just following along with that. And you'll end up constraining the hand to the arm control itself, and then the PV control maybe to the other hand, so it all follows along. So you'll need some sort of constraint set up there. But the space is going to be the most useful. And clavicle, yeah, if it's up here, so if I've got this, you could use the clavicle controls and constrain the hand to the clavicles. It really just depends on where you're going. If the hand is here, you'll want to constrain it to the upper arm control. If it's crossed like this, maybe they're holding their hands like this, lower arm. It'll really just depend on where you have it in your shot. So hopefully that helps. And if you have questions on that, let me know. And it is a cute rig, Edward. The Reimu rig and the Sine rig, they're really good. And both of these are by Mega Boo Boo, if I remember the username correctly. Awesome rigs. I really love them. They're just so appealing. Now, there are any other questions. Does anyone know how to do parent controls where one item stays with the other? Let's see. Parent controls. Do you mean constraining them together, or just like, let's say you have a root control, like the rig here. You've got a control and both objects are staying with that root control. If you can give me an idea of what you're trying to set up, what kind of prop or setup, I can do a quick demo on that. Let's catch up here. And FlowCube, hello! Okay, I missed a question earlier, so I'm just going up. I want to make sure I get it. And if I ever do miss questions, always feel free to repost them. See, I don't have money to sub, but I can send you in camera to gift. Oh, that's super generous of you. Whatever you want 3D printed and painted. Oh, that's cool. You do 3D printing and painting. I have a 3D printer, but I haven't had a chance to use it very much. And I've always wanted to get into like miniature painting and just painting like prints. It's just so cool. That's awesome that you do that. Okay, the control where like a ball is in a character's hand and the hand is moving. Okay, so you just want to have the character holding onto an object, and let's say I've got this, and the hand or the ball just follows the hand control. Essentially, you just want to do a quick constraint. Yeah, that looks awful when you're looking at it from different views. So let's say I wanted a ball in this hand here. What I would do is I would create a prop. And when you're creating the prop, the first thing to do is make sure that you're not just constraining a piece of geometry straight to a rig. Technically you can, but I find that's more of a pain. So what I'm going to do is I'm going to, let's say this is my prop here. I'm going to freeze the transformation so that it's all zeroed out there. And then I'm going to create a NURBS circle around the object. This can be my ball's control curve. Modify freeze transformation. So now that's all default view there. And I'm going to constrain the ball to the NURBS circle. So take the circle first, then the sphere. Constrain parent. What this allows me to do is move the circle, and now the ball moves along with that. And now I can put the ball into the character's hand right here. Something like that. And then constrain that to the hand. Now, I don't want to do a straight constraint, and thank you so much, Anonymous Gifter. Thank you so much for the gift. Super generous. So I don't want to do a straight constraint here because a constraint is a lock. I won't be able to move this prop once it's constrained. So typically what I'll do is I'll create a locator, place it where I want the new pivot point to be. So I want this to be in her palm. So I'm going to put that right around where the palm is, right here. And this is going to be the most basic of setups. I'm just going to take that and I'm going to parent the locator to the wrist control here. Now, typically, instead of the wrist control, I always try to find the wrist or the arm control. So typically it's going to be like this control here, the one at the end of the hand. It'll just give you more ability to switch between FK and IK. So I'm going to take the locator, then that control, and hit P to parent it. So now you'll notice that that locator moves along with. It's kind of hard to see. There's the locator right there. So it moves along with. And then I'm going to take the ball and constrain it to the locator. So locator first, then the ball, constrain, parent. Now the ball follows her hand, like so. And if I ever need to make any adjustments, have it roll in her hand, I can take that locator and just roll it around in her palm right there. So that's pretty much it. Constraints and parenting. Those are the two ways that you're going to want to connect things together. And this is a very, very simple setup. So hopefully that helps there. And then do we still do animation critiques? Yes, we do. After the demo today, I'm probably going to be doing some animation critiques. So if you do have a shot that you'd like looked at, definitely feel free to prepare the link. And let's see. You got a transform object parented to the armature and constrained to your ball, then to the extra object. Yeah, so let me actually draw this out here. So why do I always try to draw things out? Let's hope for the best. So let's say you've got the hand right here. So we've got the hand, bip, bip, like so. And then we've got our object, which is going to be, let's just put a cube here just so we have some perspective. Okay, so we've got our prop. The way I typically attach this, and this can go both ways, whether you're attaching the hand to the prop or the prop to the hand, it's a basically the same thing. You're going to want to add a locator here. And the most basic setup, so you've got your locator there. You will have the prop, and actually the prop is going to have a control curve right here. So the control curve is going to be constrained to the locator, and then the locator is parented to the hand control. And typically that's the control back here, not the actual wrist control there. This way it actually follows the hand regardless of if you're in FK or IK. So with this will allow you to have the object follow along and you're all good. And this is the most simple version. What you don't want to do is go straight here from the object right to the hand and constrain that. We don't want to do this. Otherwise, it'll lock the object to the hand and you won't be able to animate. And frame by frame, hey V, how's it going? Hope you're doing well. And best of luck in the other Twitch stream. It's nice to see you even for a little bit. Hopefully all is going well. So yeah, we don't want to do this. We want to have that locator. It'll give you that extra control. Hopefully that makes sense. Okay. Oh, you're on the wrong Twitch account. Okay, cool. Welcome. I'm glad you meant to be here. Hopefully all is going well with you. It's been a while. We need to chat again. We've got that in place. Okay. So going back to our animation here, and to the demo. Unless anyone else has questions, definitely feel free to ask. We've done our first part here where we snapped the FK arm. The arm was all animated in FK, and then we used our constraint setup and baking it all out to now have the arm follow the exact same motion, but now it is in IK. So we've done that whole switch, baked it out, all done. Perfect. So what happens when we have to do it the other way? So let's take a look at our next animation here. So this is our next animation, and here we have the opposite scenario. We have the arm animated in IK right there, but if I switch it into FK, so let's delete the key here just so we're not dealing with it snapping back and forth. Switch it to FK right there. We just get this. And you just got these wiggly fingers. So at this point, we need to get our IK or get our FK to match what our IK is doing. And that is tricky. And the big reason that it is tricky is that the IK is, like we were talking about before, just positional data. You have the position, the translation of the wrist in one position here, and the translation of the PV, the pull vector, pointing out over there. If I actually switch this here, I can actually just show it in Maya. So right here, there's the positional data of where the hand is there. And then we have the pull vector, which is, in this case, I think I hit it. Where's his pull vector? There's his pull vector right here. So let's remove that from the group. There we go. So there's the pull vector. So we've got those two positional pieces of data. We need to transfer that onto a set of controls that are all rotation based. So we need to get this arm to rotate in a way that matches with where the arm is lined up, while dealing with a random set of values and trying to get everything to match. It's very tricky. The thing that's going to allow us to do this is, once again, creating a hierarchy of controls that will allow us to track the proper motion and the proper rotation values. So again, why is this tricky? You'd think, okay, I just put some locators there, follow the joints, done, I've got the rotation value. Not really. Because if I just track the joint of the elbow here, and actually, let's actually do that right here. So this is going to be a quick example of why it's not just a quick constraint. So if I just take the elbow here, I'm going to constrain the locator to it. So do a point constraint and snap it to. And thank you so much, Sleep Deprived. Thank you so much for the gift. So right here, we have that following along. And all of a sudden, already we can see some issues. Look at that. We've got translation values in there. Well, there's no translation values on an FK control. Look at the rotation values. 180 degrees in X, 2 degrees in Y. Where are these coming from? Well, it's just the position of how the rig was created. I can't transfer this onto the elbow. Look at that. This should be zeroed out. And not only that, as this arm moves, these values are now going to change. But the elbow hasn't changed. It's still at 0. The elbow is moving relative to the shoulder. So not only do we have to find and translate translation values into rotation values, we have to do them relative to the separate joints. I hope that all makes sense. So it is a heavy task that we are asking ourselves to do, but it's not impossible. All it takes is a little bit of understanding hierarchies. And if we can get that, then we're going to be all set to go. So, how do we do this? Well, the first thing I'm going to do is I'm going to reset the FK arm. So let me zero this out. Now, if you have no animation on your FK arm, you don't have to worry about this step. But let's say for some reason later on you have an FK IK switch and you already have part of your animation in FK. We don't want to mess that up. So what I'm going to do first is I'm going to go to subframe in Maya. So subframes is when you go into the negative frames. I'm going to go to -20 right here. And the reason I'm going to do this is it just makes sure that I'm not going to break anything later on. Now, our whole animation here is in IK, so that's fine. Our IK is good. So I'm going to go to -20 and I'm going to switch the hand to FK right here. And then I'm going to zero out the arm. So make sure all of the translations, rotations here are zeroed out. Let's get rid of this locator. All of this is zeroed out. All of this is zeroed out. And I'm just going to delete these keys. Don't need them. And thank you, Pedro. Thank you so much for the sub. I really appreciate that. So by zeroing this out, what this is going to allow me to do is have a consistent relationship between all of these joints. If I have it already posed out, I'm not going to have an easy way of knowing how each joint relates to the other. So we want to kind of get that into a zero position right here. Okay. From there, I'm going to need to know where my joints are for each control. So I'm going to go to show joints. So now I see that joint information right there. If you need to, you might have to dig into your rig to find out how to turn on those joints, whether you find them in the outliner or whether there's a control on the rig that allows you to turn those on. Okay. Now, with all of this, we're going to now create our hierarchy of objects. So this is going to be a little... I'm just going to create the hierarchy first, and then we'll explain what each one does as we attach them in more detail. So the first thing I'm going to do is I'm going to create a group. So I've got nothing selected. It's just going to be an empty group. Hit Control G. You'll see it creates a null object. This is an empty group. And I'm going to call this arm group. Okay. That arm group is going to be the thing that tracks the overall motion of the entire thing. Now from there, I'm going to make another group and place that underneath. And I'm going to call this our shoulder orient group. And make sure, okay. Trying to type one-handed. Shoulder orient group. This is like the last setup we have. This is going to allow us to reorient our objects so that they line up with the controls of our rig, and then we're not going to get weird offsets. From there, I'm going to create a locator. Right here. Put that under the shoulder orient group. And this is going to be our shoulder locator. So this is going to be the thing that's tracking the rotational data of that arm. From there, we need an elbow group and a wrist group. So I can just take the shoulder orient and the shoulder locator. I'm going to duplicate that and place those under the shoulder locator, like so. So now this is going to be our elbow and elbow. Like so, one under the other. So you can see we're just going down, down, down. And now we take this, duplicate that again, and then place that under the elbow locator. And this is going to be our wrist. Okay. So, a complex wrist. A complex hierarchy, but fairly simple overall. We've got a global arm motion. That's going to track the overall position of the arm. And then we've got a separate group and locator for each joint so that we can orient them and then track the rotations. Now, just for the sake of it, I'm also just going to scale up our locators just so we can see them a little bit more clearly. So this is the hierarchy that we want right here. Now, we need this to follow the shoulder. What I'm going to do is I'm going to take the shoulder joint right here. So I want this to track the actual joint information. Take the shoulder joint there, and depending on the control, this might line up. So you can see the actual FK control does line up as well. It depends on the rig. So I'm going to take the joint and then constrain the arm group to that. So I'm going to go to constrain, and I'm just going to do a point constraint because we don't want it to rotate. We just want it to follow the position of the arm as it moves through the scene. So maintain offset off, good. So now that arm group is following that whole motion, and we can see here, you can see it's following that whole move right through. Perfect. Now, with this in place, I'm going to then bake out that constraint right away. So I'm going to take this arm group, go to Edit, Keys, Bake Simulation, and I'm going to bake this. Make sure I set my time range correctly, 1 to 74. And once again, I'm just going to sample by every frame just to make sure I don't lose any information. Okay. Now, it's no longer keyed, it's no longer constrained. It is only keyed right there. No constraint. I can actually delete this constraint right there. All good. Now, why did I bake it so early? The reason I baked it so early is we're going to be doing more constraints using this hierarchy onto the arm. And if I still have that main constraint there moving and following along, we're going to get a double constraint situation, which is going to create some odd jerkiness and essentially cause potential areas where it's going to miscalculate. So by baking it out now, it still follows along perfectly and we get it to track that point, but we're not going to be fighting ourselves as we go through this. Okay, now from here, we can now set up the rest of the arm. So what I'm going to do is I'm going to match the transforms, the translates and rotates of each group, the orient groups, to match the joint or the control on the rig. It's going to be different for each rig, so you kind of have to test it out. On this rig, I believe the joints are more accurate. So what I'm going to do is I'm going to select my shoulder orient group right here. I'm going to then select the shoulder joint right there. Go to Modify, Match Transformations. I'm going to match everything except for the scale right there. So hit Match Transformation. And you see how that slightly realigned it right there? Boop. Now it's going to match that proper orientation right there. Now I'm going to do that for the elbow orient. Select that, then the elbow joint. Match the transformations. I just hit G to repeat that last command. Now it's aligned with the joint right there. And then I can do the same with the wrist. Now, just as an example here, let's take that elbow orient and match it to the actual control. And you'll notice in this case, I just hit G to repeat the last command. It didn't move. So on this rig, it actually might be fine either way. You'll notice on some rigs, there's a slight offset. If that's the case, just experiment, see which one works better. Now, let's do that with the wrist as well. So wrist orient, then I'm going to select the wrist joint right here, modify, match transformations right there. Okay, so this now has all of our joints in the correct positions. They are matching each other correctly. Now I will constrain the locators to the joints. So what this gives us is this positional data, but you see that nothing follows. Now, if I take my locators, I'm going to constrain those to my joints. So select the joint first, then the locator, constrain, parent constrain, and I'm going to make sure maintain offset is turned on this time because I want those locators to stay absolutely zeroed out. So take this, constrain, joint, locator, constrain. Okay. So why all of this hassle? Well, by orienting that control right here, we make sure that the locator is lined up with the actual joint in the rig, but that its value still stays zeroed out. This is important because all of our controls are zeroed out. Right there, 0, 0. There's no rotation or translation values in these yet. So we don't want anything to be on our locator yet either. And then by constraining the locators to each other, and because they're in a hierarchy, now they'll follow along like so. And you'll notice that their values will match what's happening on the control itself right there. So we're getting pretty much one-to-one movement on this, which is very, very good. Now, this is where it gets a little bit more complicated. Depending on the rig, you might also need to match the rotation space, the rotation order that the controls are in. So if you select your FK shoulder control, for example, open up the attribute editor, you'll notice that this control is in ZYX rotation order. Our locator is in XYZ. Most rigs that I've tested it on, doesn't really matter. Some rigs, it does matter. So if you want to be extra just careful, you want to just make sure that those match. ZYX, this is YXZ, YXZ, and then this is YZX, YZX. Like I said, you don't always have to do that, but for the sake of making sure, we can do this right here. Now everything follows along, great. And because we constrained everything to the joints themselves, if we now switch to IK, so we didn't constrain anything to the FK controls, we just constrained to the joints, there we go. And these have all the rotational values that we now need for each joint. Right there. You can see. There's our rotations. Here on the elbow, hey, look at that. It's only the rotate Y. And it goes through the entire scene. There we go. So now we have all of our rotations. It took a little bit of setup, but we've got this hierarchy of joints, and I should say a hierarchy of locators that is giving us that feedback. From here, all we need to do is bake out the locators. Now, you don't necessarily have to bake out the locators. You could, I wouldn't do this. You could constrain the FK controls to the locators, but keep in mind that the FK controls are controlling the joints. The joints are moving the locators. And if the locator is moving the FK control, you've just created a circle, and it's going to have some mathematical nightmares happen. So before we do anything more, we need to bake out all of these locators so that there's no more constraint data here. So I'm going to take all of these, and then I'm just going to go to Edit, Bake Simulation right here, make sure it's set to 1, and I've got my correct frame range right there. There we go. So with that, all of it is keyed. I don't need my constraints anymore. If I wanted to, I could delete these. There we go. And you can see there's our animation information right there. At this point, I would want to double check that I don't have any extra rotations on my X and Z axis here on the elbow, just in case. Sometimes you'll get like 0.25, like little tiny values in there. Just get rid of them. We don't really need them. And then at this point, I can switch back to FK. And I can constrain my FK controls to match my locators. You can see the locators are still moving in place right here. So let's do that. Now, what we want to use here are not parent constraints, but orient constraints. A parent constraint is doing translations and rotations. We are just trying to get the rotation values here. So I'm going to take my locator first. That's the thing that's leading. then my FK control, go to constrain, orient, and for the shoulder, we just want to make sure maintain offset is off, and snap that. There we go, haha, it's in place. Now for the elbow, let's select our elbow locator, and then our elbow control right here, and apply that, and we get an error. See in the bottom right here, you see that red? We're getting an error. It's not creating a constraint. Why? It's because the elbow only has rotate Y. It does not have X, Y, and Z. So what I need to do here is, when I create the constraint, only add it to the Y axis here. Now if I apply that, boop, there's our elbow in place. Now we can do the wrist locator to the wrist control. Make sure we're constraining all the axes once again. Add that. There we go. Now the arm is following along. Right through there. From there, I can just bake out my FK controls. So select all my FK controls there. Edit keys, bake simulation. And then delete this group right there. And with that, the arm is now fully in FK and it's matched our animation exactly. Now, again, it might seem like it's a whole mess of steps and it's taking forever to go through. Keep in mind, I'm explaining all of this. Once you kind of get the hang of it, this would take maybe 10-15 minutes and you can have your entire 600 frame shot converted from IK to FK pretty quick and easy. Now, like I said, is this a universal tool that you can apply to every single rig? Yeah. Some rigs work much better than others. Most rigs I think this tool will work pretty well for, but it really depends. So you have to be very careful as you're setting up. Just watch the orientations, see if anything's kind of misaligning as you work, and kind of correct it as you go. But with that, we now have that full FK-IK snap and IK-FK snap, one way and the other. And there we go. So now if I want to switch back, you can see it matches exactly. There's no offset right there. As it goes through, matches exactly. So it's full FK at this point. And now I can go in there and use my graph editor and get some nice cleanup on those limbs. So for example, here there's a little wiggle in that elbow right there. Maybe I don't want to have that. I could just clean that out super easily. Get the nice ease right through there. So it just gives me a little bit of extra polish for certain things. So those are the two demos. I hope that made sense. I hope it wasn't too complex. Like I said, I am going to be writing out the actual full steps for these. And maybe if I have time, record just a quick dedicated video on doing those steps. So it's not we've been here like an hour and something. That way it's easier to follow along than a whole demo. But yeah, it's hopefully helpful. And if ever you do need that FK-IK snap, hopefully it'll come in